All right, so bell ringers put away. Let's talk about something. Okay, I want to show you something. This is really cool. All right, wait till you see this. This is neat. All right, look at the screen and check this out. Okay, here it comes. Get ready. Get ready for it. Here we go. Yeah, yeah, here it comes. Watch, watch. And bam! Oh yeah! Oh, I got a little carried away with that, and it overflew. I don't know if you caught what I did there, but yeah, there's some data missing. Data is missing. That's why I put it below. Yeah, what we're gonna do is figure. No, it's not the baking soda and vinegar reaction. Nope, I promise you it isn't. You'll see, it's not. But we are gonna figure out what this is, and we're gonna look at the data below. I know the numbers. Yes, I know. I know. Look at the numbers. We're gonna do this together, okay? Yeah. Yes, it's gonna involve making graphs. We're gonna have to do this together. So let's push through this. Okay. First of all, we have 4 beakers. You just saw one of them. There's 4 beakers. All of them have 125 milliliters of water in them. The water's temperature is calibrated, to find out what it is initially. But then 20 grams of a substance is added. So in beaker 1, after the 20 grams of substance is added, you can see after 10 seconds, 20, 30, 40, 50, all the way up to 2 minutes, temperature readings were taken. Same for beaker 2, 3, and 4. So what you have is a challenge now. What I have is 2 handouts for you. One is to plot the temperature on the graph sheet, and 2 is another one to determine whether you think beaker 1, 2, 3, 4 is a physical or a chemical change based on this information. So go ahead and get started with plotting the data on your graph, and let's look at the results in a minute. All right, so when I was going around the room, I did notice a lot of you getting the lines plotted, and you knew you had to basically plot 4 different beakers. So some of you did dash lines, solid lines. Some of you brought colored pencils. That was cool. Just to notate the 4 different beakers in your data. Well, I grabbed somebody's. It's no name, but I noticed the same things you all noticed. And from the data, actually, going across from left to right, I noticed beaker 1 and 2 did have an initial temperature drop from the beginning temperature of water, but not quite as much as beaker 3 and 4. In fact, 3 and 4 both dropped very quickly, and 4 dropped the lowest temperature of all, and then even had a little rise of temperature in the end, and the data shows it. So this was a really cool student example. I just wanted to grab off of someone's desk and share with you. But you know what? I gotta be completely honest with you. I didn't provide you enough information to fill out the next thing, which of course, is making a prediction whether it's a physical change or a chemical change. Yeah, that was a little wrong on my part. But some of you put beaker 1 and 2 as just a physical change. Some of you put 3 and 4 as a chemical change. I saw some of you putting 1, 2, and 3 as a physical change and beaker 4 as a chemical change. But based on what? There was temperature change. At this point, we've learned chemical changes. They sometimes have a change in color. Sometimes a gas is produced. Sometimes another state of matter is produced. Sometimes it's always irreversible. And so from this information, only temperature change, we definitely don't have enough information. So let me share with you what I should have shared with you. This information. Does this help any? I purposely left a little space on your paper in order for you to fill out the missing information. Take a little time to fill out this information and then see if you change your predictions as to which is a physical change or a chemical change. All right, so some of you did actually change your answer based on this information. See, it helps to have more information. All right, speaking of that, which beaker do you think it was I showed you in the beginning? Was it beaker 1, 2, or 3? Which one? Yeah, maybe you're right. The next slide will tell us for sure. Is it beaker 1, beaker 2, or beaker 3? Watch and see. There it is. Yep. It was the citric acid and baking soda reaction. Told you it wasn't vinegar. Anyway, so what we have here is some classic adding some substances to 125 milliliters of water, and you get some temperature changes, but two dramatic temperature changes. Did you happen to notice what beaker 4 was? Yeah. So here we have beaker 3 and beaker 4. This is where we're going with this. Beaker 3, beaker 4. They basically both have 20 grams of a substance being added. One, now you know, is citric acid and baking soda. The other one, just good old solid water, ice. And the data below shows us the temperature change. Did beaker 4 fool you? Did you think that drastic temperature change may have been a chemical reaction? If it didn't, good for you. If it did, that's okay, but you didn't have all the information. Remember, in science, we make observations and we collect data, then we make our hypothesis. So we didn't have enough information to be very accurate. But there's something happening here. And I am going to challenge you. The challenge is going to be on the next slide. Here you will see what your handout is. It's a handout to develop a model. You're going to make two models. One to describe what's going on in beaker 3, and one going on in beaker 4. You're to use the data that you have below and the observations that we have of what's been going on in beakers 3 and 4 during that temperature change. So remember, you need to label everything. Label that glass beaker. Label the water. Label the citric acid and baking soda. Label the ice. Label everything. But don't forget to add a prediction below in the data table and an explanation in your beaker. What's the prediction? The prediction is, what will the temperature be in 24 hours from now? So do your best to explain what's going on currently in the reaction of beaker 3. Explain what's going on in beaker 4. Be detailed. Use explanations that involve chemical and physical changes. And make sure you make your prediction. That's your challenge.